Hello. Let's begin our class. Uh, Yesterday, I updated our course website, and assignment 1 has been posted. And the deadline of the assignment 1 is 3 weeks later. And if you want to submit your assignment, then you need to follow the submission rules. And the easiest way is to use the provided email link. After you click this link, then here is the target email address. This address will be automatically filled, and also the title of this email will be filled. Then you need to attach your CPP file, and remember that the file name of the CPP file is your student ID. So the beginning of the file name should be your student ID, and after student ID you can put any words you want. And email content is your name, so that I can know who sent this email. And let's see the submission rules. After you send your assignment, I will not reply. If you want to check whether the submission is successful, then you can check your sent folder. And if you find any mistakes, for example, you send the wrong file, then you just fix the error and resend your assignment. My grading will based on the latest assignment I received. So if you find any mistakes, then you just fix the mistake and resend your assignment. So I recommend that you always check your sent folder. For all the assignments, the receiver address is the same. This is my second email. And for the assignment 1, the email subject line is assignment 1 PRGB. Here PRGB is fixed for this course. And for the next assignment, then you replace assignment 1 with assignment 2. And for the third assignment, you replace assignment 3, assignment 1 with assignment 3. And for assignment 1, you cannot add a space between assignment and the 1. These two are different email subjects. Below is some example for your attachment for the file name for the file name of your CPP file. Below are some valid examples. So the file name should begin with your student ID, and after your student ID, you can add any words. Below also provides some invalid file names. For example, this one is invalid because this one does not begin with your student ID. And also remember to send the real CPP files. Do not send links to your CPP on the cloud. It is also suggested to modify the setting of your operating system to show the file extensions, because by default Windows 10 will hide the file extensions, so you may not able to see the CPP extension. And let's see. Below are some notes. I will update the accuracy of each assignment every week until the deadline. Below is one example. For example, if you submit your assignment by 9 p.m. on 24 September, then you can see your program's accuracy on the next date. However, if you submit after 9 p.m. on 24th September, then you have to wait your accuracy updated next week. And if you find the program accuracy is not 100, then you can revise your assignment and resubmit until the deadline. So so send your assignment as early as possible is recommended, because you have the opportunity to fix your assignments. And next, I will explain the contents of assignment 1. For this assignment, you need to write a C++ program. This program will read a number of pizza slices. So first, the program will display this string, and then the user will enter some number. This number is between 1 to 1000. You don't need to check this number. You can assume the user input is always a number in this range. Then this program need to compute the smallest possible combinations of the following four slices. The first one is whole pizza. Whole pizza corresponds to 8 slices, and the half pizza corresponds to 4 slices. Quarter pizza corresponds to 2 slices, and the single slices. So you need to perform. You need to convert the user input to 4 numbers. So for the following example, 83 corresponds to 10 whole pizzas, and 0 half pizzas, and 1 quarter pizzas, and 1 single slices. You can verify the answer. So 10 times 8 plus 0 times 4 plus 1 times 2 plus 1. So the sum of the 4 numbers equals 83. And you need to you need to develop your own solutions to this problem, to this question. So for this assignment, you need to develop your own solution to this problem. And here, the smallest possible combination means using as many larger units as possible. The larger units is the whole pizzas, so you need to use as many larger whole pizzas as possible. For example, if you choose 11 11 times 8 is larger than 83, so you cannot use 11. You cannot also use 9 because 9 is not the largest unit of whole pizza. So for each input, there is only one unique output. So the conversion is unique. So given one input, you always there is always one unique answer. I provided many other samples. You can see the samples from this link. So I provide 10 samples. Then you can use these samples to test your program. Your program should output the same outputs. And the assignments requires you to follow the input-output formats. If your program do not follow the input-output formats, then the accuracy of your assignment will be 0. Next, I will explain the input-output formats. The outputs of your program should be exactly the same as this example. And here, exactly the same means every character, including space, new lines, punctuation, and letters, should be the same as the provided samples. And here I provide a code template. You can see this code template. So here is the code template. You can download this. You can download this. You can download this code template. And you should read this code template first, because this template tells you the input-output formats. So you don't need to manually type these words by yourself. You just use the code template. So here is the code template, and the code template already reads the integer from the user. So and the cin will read user input and store the user input in the slice. Slice is variable. Then you need to enter your code here. You need to perform some arithmetic operations, like plus, division, these operations to this integer variable. And then you need to, and then finally you can obtain the number of whole pizzas. You can store the number of pizzas in variable 1. And you need to also compute the number of half pizzas, and you can store this value in variable 2. So you just you can remove this comment and enter your code in this place. And you don't need to worry about the output formats, because here the cout statements already output the strings required. So here you can focus on computing the desired numbers. You don't need to worry about input-output formats. So before submitting your assignments, you should check whether your program can handle the samples provided. So at least your program should output the same results as these 10 samples. Below are some incorrect output formats. For example, someone might delete the space after the column. This is considered incorrect because the output format does not meet the requirement. So you cannot delete any space or change any words. You cannot add any line. You cannot, for example, you cannot print any variable, the value of any variable. So you cannot, for example, you cannot print the value of slice. So the suggestion is to only enter your code here, and do not modify any cout statements. You cannot change the sequence. For example, you cannot perform cin first and then use cout to show the string. This is also will cause your program to be incorrect. And you cannot delete any line. For example, if you delete this line, then your output formats does not meet the requirement. So you cannot delete any line in this code template. So finally, I have some suggestions. The first one is to rename variable 1 through variable 4 with meaningful names. So you can change the file name. You can change the variable name to some meaningful names. This will make your code more readable. And for this assignment, you only use some simple mathematical operations. You don't need to use for loops or if-else statements. So for this assignment, assignment is for beginners. You only use some simple mathematical operations, then you can compute the solution. Any questions about assignment 1? If no questions, then we will take a quiz. So you can log in the Ruvio first. You can log in the Ruvio first. I haven't opened the question, so if you log in, you cannot see any question. for the quiz, you cannot use tablet or laptop. So if you should close your laptop until the quiz is over. So if you use laptop, please close your laptop until the quiz is over. And if you cannot use mobile phone, you can use paper and pen. Please raise your hand if you need the answer paper. Oh, okay. Anyone need answer sheets? Anyone need answer sheets? Why you do not use this? You should. I recommend to use Rubio app because it is easier to grade. Okay. So I open the first question. So you should be able to see the question, and the quiz consists 3 questions. Each one is a single choice question. The first one is what is the purpose of a compiler? You can use mobile phone to search the answer. You can search. Mobile phone is allowed, but laptop and tablet are not allowed. And you can modify your answer many times before the end of this quiz. You cannot input your answer. Why do you want to use paper? Oh, okay. Sir, 20 seconds left. After 20 seconds, you still can answer this question because I will not turn off this question. Next, I will turn on the second question. The second question is to choose the false statements. One of the false statements is false. Uh, 30 seconds left for this question. Then I will turn on the final question. This question is to choose the legal identifier. This is means legal variable names in C++. So below are four variable names, and you should choose the legal variable names in C++. 30 seconds left. The quiz is over. If you use answer sheets, remember to write down your name and your student ID and submit your answer sheets to me. Okay, let's let's see the answers of the quiz. For the first question, the answer is the option 3. The purpose of a compiler is to translate source code into executables. And we do not use compiler to write programs. You use text editor to write programs. And actually, you use the operating system to execute the programs. So only the third option is correct. For the second question, we need to choose the false statement. And the option 4 is the answer. Compiler cannot detect semantic errors. If you let's see the first one first. Syntax errors are easy to fix because syntax errors can be detected by compilers. Compilers can find syntax error. Then you can fix the syntax error according to the compiler's message. Semantics errors are difficult to find because it cannot be detected by compilers. So for this question, the answer is option 4. Semantic errors occurs usually because we do not fully understand what we write. If you do not fully understand what you write, then this will cause semantic errors. And for this question, for the final question, we need to choose the legal identifiers. Identifiers means variable names. And in C++, variables can begin with underscore. So A is legal, and the B and the C are not are illegal because variable names cannot begin with digits. Digits can be used in second. So digits can only be used in the position other than the first character. So the answer of this question is AD. If no questions about the quiz, then I will return to our slides. I suggest if you are students in Taiwan, I always recommend use the Rubio app. This app only has Chinese version. But if you are Taiwan students, I think you should use this app. Then you can register a new account by yourself, and you can manually add the course code. Then you can see this course. Let's see the slides. In the previous week, we talked about identifier. The identifier is the name of variable. So the variable name is the variable's ID. So it is called identifier. And here are the rules for the identifier. And in C++, we have some keywords or predefined words. And you cannot use these words to be identifiers. For example, you cannot use switch as variable name because this word is a reserved word in C++. You cannot use return as variable name. So these keywords shown here cannot be used as variable names in C++. C++ has some predefined words. Predefined words means they are not keywords, but they are defined in some library. For example, IOString. In IOString, the library defines cin and cout, the two variables. The predefined words are not part of the C++ language, and you are allowed to redefine the predefined words. But this is not recommended because this can confuse others. Because we usually assume cin is to read user inputs and cout is to output some values. If you use cin and cout as variable names, then this will be confusing to others. In C++, if we need to use a variable, then we need to declare this variable. And to declare the variable, you need to choose the data type. So here int means integer. Integer is a data type in C++. So you use data type and followed by the variable's name, and then by a semicolon to terminate this statement. Or you can declare many variables in a single line. For example, here double is another data type. You use double to declare one weight, the first variable, and the total weight, the second variable. And you use the semicolon to terminate this statement. So this statement declares two variables. Both data type is double. Next, I will introduce simple data types. Simple data types means built-in data types in C++. You can also use user-defined data types to declare variables. Later, we will learn how to define our own data types. And here, I will introduce the built-in data types in C++. And there are 4 categories. The first one is integers. The second one is floating point. Third one is character. Fourth one is boolean. And for integers, we have three data types: short, int, and long. All of these 3 can be used to declare integers. The difference lies in their memory space. Short, the memory space of short is less than that of int. And similarly, the memory space of int is smaller than that of long. Here is one table to show the integer size on different operation systems. For the integer data type, in all operation systems, integer data type occupies 4 bytes. And however, for the long data type, the size of the long data type will varies on different operation systems. For example, on 32-bit systems, long has 4 bytes. However, on Unix 64-bit, the long has 8 bytes. And this will cause some portability issues, because if your program use long to declare some variables, and your program works well on a 32-bit system. Suppose your program works well on a 64-bit system, but when you compile your program on a 32-bit system, this might cause problem. Because in the 64-bit operation system, the memory space is 8 bytes, and you can deal with integers with larger size range. However, if the long only has 4 bytes, then the size range is much smaller. And if the value is over the size range, then your program will have problem. Later, I will use some example to demonstrate this. And we also have one keyword for the integer data type, unsigned. Here, unsigned means uh, unsigned is you can add unsigned before short or before int or before long. Unsigned means only non-negative values. So non-negative means either 0 or either positive. And if you do not add unsigned, then the three integers can be either negative or positive or 0. But if you add the unsigned keyword, then the value is always non-negative. And in C++ 11, 2011, the committee introduced some new integer data types. And these data types specify the precise memory. For example, int 8 means here 8 means 8 bits, and 8 bits correspond to 1 byte. So you know the memory size from the data type's name. And similarly, uint means unsigned int, and int 32 means 32 bits, and 32 bits corresponds to 4 bytes. And int 64 means occupies 8 bytes. And you notice that the size range for unsigned int is always begins from 0 because it is non-negative. But for integers without unsigned, then the size range can contain negative numbers. Later, I will explain how to compute the size range. Time is up, so let's take a break for 10 minutes.
喂，请问一下，那个座号10号在吗？有吗？在的举手。座号10号，全英班座号10号。好，不在。那26号在吗？26。好，没事了。
Hello. Let's continue our class. Uh, let's talk about the size range of integer of unsigned integer 8. We know unsigned integer 8 has 8 bits, and 8 bits means each bit is either 0 or 1. So we have we have 8 bits, and this means the number of possible combinations is 2 to the power of 8, and 2 to the power of 8 is 256. So we have, so this data type unsigned integer 8 can deal with 256 number of combinations, and the size range begins from 0 for C or C++. Well, we usually start from 0. So from 0 up to 255, we have the size range is 256. So this is the size range of the unsigned integer 8. And for the integer 8, this data type deals with negative numbers. So its size range begins from negative 128 up to 127. But its length is the same as unsigned integer 8 because they are both 8 bits. So you can count the number from negative 122 up to 127. The number of elements is also 256. And the same rules applies to larger data type. For example, for unsigned int 32, and we have 2 to the power of 32. And since we begins from 0, so its maximum value need to minus 1. And for the int 32 data type, and because it can deal with negative numbers, so we begin from negative 2 to the power of 31. So you see the same rules applies to larger integer data types. So once you know its memory size, you can determine its size range. For example, you know if the memory size is 32 bits, you know the size range is from 0 up to 2 to the power of 32 minus 1. And if this data type deal with negative numbers, then you need to divide the maximum value by 2. Then I will then you might wonder, there are so many integer data types, which one should I use? And this usually depends on your application. If your size range is small, for example, your size range is within from 0 up to 252, then you should choose the unsigned integer 8. You should not choose larger integer data types, because this can waste memory space. We know memory space is limited. For example, in my laptop, for my laptop, the memory space is only 8 gigabyte. So the memory space is limited. And if you are a programmer, you should use the smallest. You should use the least memory as possible. So you should, if you are a programmer, you should use the memory efficiently. So whenever you can use 1 byte, you should not choose larger integer data types. For example, suppose you take a picture and the picture is suppose the resolution of the picture is 1024 times 720. Then for RGB images, you also need to times 3. So for a picture of this resolution, the number of pixels is this one. This is very huge number. And if you write a program to load this image, then you will have this number of variables in your program, and then you need to choose for each variable. You need to determine its data type. So we should always choose the smallest data type that can deal with the your size range. For this example, for an image, its element we call a pixel, and a pixel ranges from for a pixel, its range is from 0 up to 255. So this is exactly the same as the size range of unsigned integer 8. So we usually use this data type to store the value of a pixel. We don't use larger integer data type because this will waste memory space. Then here I will use one example to illustrate the importance of size range. Now suppose we use unsigned int 8 underscore t. We use this data type to declare a variable pixel, and we assign some initial value, for example 250. Then you can print its value. You can print the value of this variable, and you will see some noise. This is because it is treated as a character. If you want to see its numerical value, you need to perform typecasting. You need to change its data type to int. Then this will show the numerical value, and its numerical value is 250. And then we can perform some addition. For example, we add For example, we add 5. Then the result should be 255. Now suppose you add 6. This will cause a problem because the size range of of unsigned int 8 is from 0 up to 255. And if you perform addition, you add 6 to this number, the result is 256. It's over the maximum value, so it's outside the size range. Then you can guess what will happen. Will this cause a syntax error, or this will cause a runtime error, or nothing happens? So you can take a guess what will happen if I run this code. Will the compiler detect a syntax error, or some runtime error, or here just print 256? We can run the code. You see that the code can be compiled correctly. This means the syntax is correct. So the syntax is correct. This means the compiler will not detect the size range. So even if the value is outside the size range, the compiler will not detect this. The compiler will not detect the value is whether the value is outside the size range. And the second, you notice that the output should be 256, but the program outputs 0, not 256. And this is called overflow, because the value is outside the size range. So this is known as overflow. Now suppose I add 7, then can you guess what will print on the screen if I add 7 rather than 6? This is also called overflow because the result is 257, and 257 is outside the size range. So you can take a guess. The answer is 1. The program will output 1. Similarly, you can do more experiments. If you add 4, then the program outputs 2. This is because if you outside the size range, then you will start over from the smallest value. So if the value is 256, then you will start again from the smallest value, 0. So 256 is 0, and the 257 is 1, and the 258 is 2. So it is important to know the size range of integer data type of small memory space, because it is easy to over the maximum value. Now let's change this example. Now suppose I use int 8 to declare a variable. Now its size range is different. Its size range is from -128 up to 127. And here I change the initial value. So here pixel is 127, so the program outputs 127. This is what we expect. And if I modify 7 to 8, then we have a problem, because here pixel is 128, and the 128 is outside this size range. And do you know what will be printed on the screen? Now we are outside the size range, and what will print on the screen? Let's see the answer. The answer should be negative 128. The rule is the same. If you outside this size range, then you will start over from the smallest value, and the smallest value for this data type is negative 128. Similarly, you can add. If you add 9 to this number, we have 129, and you will start from negative 128. So this will become negative 127. So if the value is over the size range, then this value will not be the same as what you expect, because we expect that the value is 129, but here actually the value is negative 127, and this problem is known as overflow. So if you do not pay attention to the size range of the data type, then you may encounter the problem of overflow. And next, I will introduce another operation related to the integer variable. This operation is known as left shift operator. Here is the precedence table for the C++ operators. Later we will introduce this table. And now let's see this. Now let's see the left shift operator. This operator is used to perform bitwise shift, and the bitwise shift is applied to binary number system. So first we need to know what is a binary number system, and then let's you can go to the syllabus. I provide a reference web page, and you can go to this reference web page and go to the C++ basics. And here is one tutorial. This tutorial will teach you how to convert, to understand binary number system and decimal number system. And in our daily life, we use decimal number system, so we are familiar with decimal number system. But for computer use another number system. Computer familiar with binary number system, so we need to know the conversion between the two number systems. And here is the decimal number system. For example, if you write 123 in base 10, base 10 is the decimal number system. It's what we use in our daily life. When you write 123, what does this number mean? Actually, this number means 1 time. So for this number, then you need to first you need to determine the position of each digit. We start from the far right digit. We start from 3, and the 3 is position 1, and the 2 is position 3 is position 0, and the 2 is position 1, and the 1 is position 2. The position will be used to denote the power. So here 0, position 0 represents 10 to the power of 0, and the position 1 means 10 to the power of 1. Similarly, position 2 means 10 to the power of 2. Then we need to multiply the digits with this position. So here 3 times 10 to the power of 0 equals 3 times 1. So the value is 3. And we move to the position 1. And the 10 to the power of 1 is 10. So 10 times 10 is 20. So for the second digit, we have 20. And for position 2, 10 to the power of 2 is 100. And the 1 times 100 is 100. So we need to sum the 3 numbers. So here, if you sum 100 plus 20 plus 3, we obtain 123. So this is the meaning of this number in decimal number system. And similarly, you can use this concept applies to any other number system, including binary number system. For example, now you return a number in binary number system, 10010. We know that each digit is either 0 or 1, because it cannot larger than 2, because we are in a binary number system. For decimal number system, the digit is at most 9. So you know that the digit in this number system is at most the base minus 1. So the digit is at most 9. The digit is from 0, 1, 2 up to 9 for base 10. And if the base is 2, then the largest digit is 2 minus 1. So for this binary number, we need to determine its decimal value. And the computation process is similar to decimal number system. And first, you need to determine the position of each digit. And we start from the far right digit. So we begin with position 0, position 1, and position 2, and so on. And then you compute the value. You need to, for example, you raise in position 0, you raise you compute 2 to the power of 0. In position 1, you compute 2 to the power of 1. And then you sum all the numbers to obtain the decimal value. So for example, in position 5, we have 1 times 2 to the power of 5, and the 5 is the position index. And the 2 to the power of 5 is 32. So you can compute all the numbers corresponding to each position, and you sum all the numbers in this position, and you obtain 32 plus 2, which equals 34. So 34 is the decimal value of this binary number. And actually, you can do the reverse process. Here, I will show you. If you want to start from 34 decimal number, you want to convert to binary number system, then you can perform division. First, you divide 34 by 2. Then you pay attention to the remainder. The remainder is 0, because 34 divided by 2 is 11, and the remainder is 0. So here, remainder is this digit. Then you need to deal with the quotient. The quotient is 74 divided by 2, which is 17. Then you perform 17 divided by 2. Now the remainder is 1, because 17 is an odd number. So here, 1 is the remainder. Then you do the similar process. 17 divided by 2 is 8. So the quotient is 8. Then you divide this quotient by 2. So 8 divided by 2, the remainder is 0. Then you obtain quotient 4, and quotient 4 divided by 2 is also 0. Remainder is also 0. Okay? And you can continue this process until the quotient is 0. In this way, you can convert a decimal number to a binary number system. So if you are not familiar with binary number system, I suggest you can read this tutorial. This tutorial can help you understand what is a binary number system. And then we will move to the left shift operator. We will move to the bitwise left shift operator. Now suppose we declare a variable, and its initial value is 6. Suppose the initial value of x is 6. Then we perform left shift by one digit. And then we want to know the value of x. To do this, we need to compute its binary representation. So 6 equals 1, 1, 0. So 6 corresponds to 110 in binary number system, because 0 plus 1 plus 2. Here here is position 2, and position 2 corresponds to 2 to the power of 2. So this number is 4. 4 plus 2 is 6. So 110 corresponds to 6 in decimal number system. Then you perform left shift, and this means 1100, right? Because you perform left shift 1 digit, so 110 becomes 1100. Then do you know what is the value of x? What is the value of x? What will be printed on the screen? So what is the decimal value of this binary number? If you perform some computation, anybody know the answer? What is the decimal value of this binary number? 12. Oh, very good. Someone say 12. The answer is 12. Now suppose I change the value of x. For example, 120. Sorry. For example, I change it to 100. Anybody know the result? I can directly tell you the result. The result is 200. And if you change this to 110, the result is 220. So I did not perform the conversion. You know why? I did not perform the conversion to binary number system. Because you have another way to understand this operator. Here, you have another way to understand this operator. Because if you perform left shift by 1 digit, this actually means you multiply this number by 2. You multiply this number by 2. So if you change the value of x, if you change this value, then the left shift corresponds to multiply this value by 2. So the result is 110. Now let's try another example. For example, you perform left shift by 2. Then do you know the answer? Now I perform left shift by 2. We can start from the basics. 5 is 101. And if you perform left shift by 2, we have 10100. So what is the decimal value of this binary number? $20. Oh, very good. The decimal value of this binary number is 20. So the result you see, the value of x is 20. Now we can choose another challenging problem. For example, here we have 7. Sorry, 7. Sorry, we have 11. So now suppose if the initial value is 11, and you perform left shift by 2 digits, and do you know the answer? Oh yes. Oh, you know the trick. The answer is 44. The answer is 44. And similarly, if you use 110, then the result is 440. Because if you perform left shift by 2 digits, this is equivalent to multiply this number by 2 to the power of 2, and the 2 to the power of 2 is 4. So this is equivalent to multiply x by 4. So if you perform left shift by 2, then you can, the easiest way is to perform multiplication by 2 to the power of 2. So actually you don't need to compute its binary number representation. So if you can also shift 3 digits, and this time it corresponds to 2 to the power of 3. So equivalent to multiplication with 8. So the result will be 880. Also here, similarly, you can perform right shift. Right shift means division. So if you right shift one digit, then this is equivalent to divided by 2. So the result will be 55. And actually in C++, we often deal with another number system. We often deal with hexadecimal number system. Here is one example. For example, later we will learn pointer. The pointer is deal with memory space. Now suppose you want to print the memory address of X. Now suppose I want to print the memory space of this variable X. Then you just add the ampersand operator before X. Then you can see its memory address. And this memory address is in a different number system. It's hexadecimal. If you see a number begins from 0x, then this means this number is in hexadecimal number system. So for the memory space in C++, we usually deal with hexadecimal number system, and each digit starts from 0 up to 15. And for digit 10, we often use letter A, and for digit 11 we use letter B, and for digit 15 we use letter F. So when you see, you will see number like this. F corresponds to digit 15. And actually, you can try to play with hexadecimal number system. For example, you can try 0xf. This means x is 15. This means because f corresponds to 15, and this number begins from 0x So this is a hexadecimal number. Its value is 15. You can also compute what is FF. What is FF in hexadecimal number system? It is this number should be 15 times 16 and plus 15. So the number should be 255. So you can also play with hexadecimal system. Actually, this is more precise. Precisely, this corresponds to this is 16 to the power of 1, and this should be times 60. So actually, this hexadecimal number means F15 times 16 to the power of 1, because this corresponds to position 1, and this corresponds to position 0. So so after you compute a number, you obtain 15 times 16 plus 15 times 1. So this is the same as decimal number system. So all the number system use the same way to compute its value. Actually, here is one. I also provide some link for you to, if you want to do more practice. Here is decimal to binary. You can type any decimal number, then this will automatically convert to its binary representation. You can verify. You can verify. Or it also provides hexadecimal number system, and you can verify whether the number equals this decimal value. For example, 7b should be 123 in decimal. Then you can try 7b in your program. So here I try 7b. Then this should be 123. So here 7 means you replace and in the one final note about the left shift operator. Here, if you use cout, you also notice that you also use the left shift operator. But for cout, we do not perform bitwise operation, because for cout, this operator has a different meaning. Its meaning is to direct the value on the right hand side to the screen output. So here, if you use this left shift operator with cout, then this operator does not perform bitwise left shift. This is known as operator overloading. This means an operator can have different meaning in different context. So an operator can have different meaning. Later we will learn more about this. This is known as operator overloading. We will learn overloading in later chapters. Next, let's see another data type. This data type is floating point, and similarly, we have some floating point data types, including float, double, long double. And the memory size of float is always fixed to 4 bytes, and the memory size of double is fixed to 8 bytes, regardless of the operation system, because this is specified by the IEEE 754 floating point specification. And the floating point use a different method to store a number. So you need to pay attention. This is a different number system. So this is different from integer. So let's see how this data type handles a floating point. We start from the float data type. And this data type has 4 bytes. 4 bytes means 72 bits. So this data float has 72 bits. And the leftmost bit is used to represent the sign of this floating number. So you see, this is a blue 1 bit. This blue bit. This is used to represent the sign. The sign is either positive or negative. So if this the value of sign, if it is 1, then this means floating point is negative. And if the sign is 0, means this floating point is positive. Or 0, and the following 8 bits will be used to denote the exponent of a floating point. Exponent is the scale of this number. So scale means how large or how small. So the remaining 8 bits is used to denote the scale of this floating point number, floating point. And the remaining 23 bits is called the fraction. Fraction means the actual digits stored in this variable. The precise conversion is a bit complex, and I will skip this conversion process because this actually belongs to another course. But you can understand the basic concepts about floating point. Here I also provide a web page. In this page you can see the conversion from a decimal representation to a floating point representation. For example, I type for example, when you type 3.14, then this will correspond to a binary representation. This will correspond to the 32 bits. If we suppose we use float, then float will has 32 bits, and its binary representation is this number. It is positive, so the first bit is 0. If it is negative, the first bit will be 1. So the first is sign bit, is determine the sign of this number. And the remaining 8 bits is used to denote its scale. So you see that it's 1 0 0 0. Here, this rate mark corresponds to 1, and the white box represents 0. So you see here is 1 0 followed by 7 zeros. And then the remaining 23 digits corresponds to fraction. So here is the fraction. Fraction is 1 0 0. Here is 1 0 0 1 followed by 3 zeros. So this is the binary representation for this floating point, and this corresponds to so if you assign a decimal number, this is decimal floating point, to x, then you can print its value. But you say the number is 3 point. Time is up. So let's take a break for 10 minutes. Hello. Let's continue our class. Let's return to our example. Now suppose suppose you enter 3.14. Then what will store in the variable is not this value. It's not exactly this value. Actually, the value actually stored in float is this number. And you will notice a minor error due to this conversion. And we can write a program to verify this. Now suppose you assigned the same. You assigned 3.14, and this is the we use float to declare x. So x is a floating point, and it will use 32 bits to store this number, and the value actually stored is this binary representation. And this binary representation, if you follow the IEEE 754, then you will find this binary representation corresponds to this number, and this number is slightly different from 3.14. You notice the residual here. The residual is very small. So this means the floating point is not accurate. It always contains some small residual or small errors. And you can try to print the value of x. And you will say it's the same. The value of x is 3.14. But this is not true. This is not true. The value of x is not 3.14. This is because you do not specify enough precision. You can here, if you specify the precision. Now suppose if you specify the precision to 20, then you can see more digits after the decimal point. So you see, if I adjust the precision to 20, then you can see 20 digits after the decimal point. And you will see this number is actually different from 3.14. So actually x is not exactly the same as 3.14. This is due to the conversion. The conversion always contains some conversion errors. Now let's try another example. Sorry. Suppose I adjust its precision. For example, it's 1. So this will if the precision is 1, then it will perform rounding. It will round to the 1 digit. So this will print 3.1. Similarly, if you round 3.16 to 1 digit, then this will print 3.2. Now we can try another example. For example, if you try 3.15, then can you know the answer? It's 3.2 or 3.1. So the for this program output, if you think the program output is 3.2, please raise your hand if you think the program output here is 3.2. Nobody. Oh, okay. If you think the program output is 3.1, please raise your hand. Oh, also nobody. Oh, let's see the outputs. The output is 3.2. But this is weird because you think 5 after rounding, this should be 3.2. Sorry. It's 3. I change another example. For example, for 3.06, and if you specify precision is 1, and after rounding it's 3.1, because 6 is larger than 5, and after rounding this will be 3.1. However, if you choose 3.05, the program output is weird because after rounding, this is not 3.1. Anybody know what is the problem? Because 3.05 after rounding to precision 1, the result should be 3.1, right? Not 3.0. But why this program outputs 3.0? You can try the code in your computer. I believe the result is also 3.0. This is because the value stored in X is actually smaller than 3.05. This is let's see. You can use this converter. Suppose now we type 3.05, and you will observe that the value actually stored in float is less than 3.05. It's 3.04999. So it's very close, but smaller than this number. So after rounding, the value is 3.0, not 3.1. So we should pay attention to the usage of floating point, because there is always some small residual or error between the value actually stored in float. So if you want to see if you want to see its real value, you should add more precision. You can specify more precision. Then you can know the value actually stored in this variable. So you see the value of X is not 3.05. It's close, but not exactly the same. Okay, and we have finished the introduction of this floating point. And next, we will move to the next slides. The next slides is about the size of operator. And you can use this operator to obtain the memory size of a constant or of a variable or a data type. So for example, size of 10. So size of x will return its memory size in bytes. So float has 4 bytes. So this operator will return 4. And if you input 3.05, the answer is 8. The answer is 8 because this is a constant, and this constant is double. So C++ assume a floating point constant as a double, and a double is has 8 bytes. So size of double will return 8. So you can try double. Double will return 8. You can also try another data type. For example, character. Character has 1 byte, so this will return 1. And you can try. You can try integer. Integer has 4 bytes. Short is another integer data type. The short data type has 2 bytes. So you can use the size of operator to obtain the memory size of constant, variable, or data type. This slide is about a keyword auto. If you perform assignment in declaration, then this keyword will automatically determine the data type of X based on its initial value. So if the initial value is floating point, then the data type of X is a floating point. If the initial value is a string, then is a character, then the data type of X will be a character. So auto means automatically determine the data type based on the expression on the right hand side. Next is about the assignment statement. You can use assignment to change the value of a variable. So on the right hand side is an expression. Expression is any operation that generates a value. So expression can be a constant, a variable, or some mathematical operations, or a function call. So expression can be any operations that generates a value. On the right hand side is always a variable. So on the left hand side, left hand side is always a memory location. The right hand side, left hand side is called L value. So L means left. So the value on the left hand side is called an L value, while the value on the right hand side is called an R value. the L value is always a variable. The L value cannot be a constant. And if you try to perform assignment, for example, if you try to assign some value to a constant, this will cause syntax error. Because on the left hand side, the L value should be a variable, not a constant. And if you perform assignment, actually assignment will generate a value. If you assign 2 to m, then this assignment will generate 2. And you can use the generated value to assign to another variable. But this is not recommended because this can decrease the readability of your program. Next is about how to initialize a variable. When we declare a variable, you can also initialize its value. In this example, I initial 0 to count. And we have another way to initialize a variable. You can use parentheses. And inside the parentheses is its initial value. So the two statements perform the same initialization to variable count. And do you know if I do not initialize count, what will be the value of count? Now suppose I declare count. So do you know what is the value of count? If I do not initialize this variable. The answer is unknown. You do not know its initial value. So if you do not initialize value in C++, its value is unknown. And the one common mistake is many students assume its initial value is 0. So this is one very common mistake for beginners. They often forget to initialize a variable and assume this variable is 0. This is one common mistake. So some students perform operations like this. They declare variable count and then perform some mathematical operations. For example, add this number by 1, and they assume the number should be 1. But you see, actually, the answer is wrong. But in your computer, your answer might be 1 in your computer, because different computers will output. The output will be different because here is the value of this variable is unknown. So we always initialize variables. So it is a good habit to always initialize a variable. And we have some shorthand notations for operations like this. If you want to perform count plus 2 and assign this value to count, you can use a shorthand operator. You can use plus equal. You can use plus equal to denote this assignment and addition. Similarly, you can also use minus equal to denote this statement. The next one is also about assignment. When we want to assign some value to a variable, then the data type should be matched. For this example, the right hand side is a floating point. The left hand side is an integer, and this causes a type mismatch. And some compiler will try to perform typecasting. It will convert the data type from floating point to integer. But this will, in this example, this will lose some precision, because if you convert 2.99 to either 2 or 3, this will lose some precision. So compilers may or may not accept the above mismatch. However, if you want to assign some integer to a floating point, this is always legal, because the compiler will convert the integer 2 to floating point 2.0. So this causes no precision loss. So this is always legal. The next slide is about constants. Constants is in contrast with variables. Constants means we cannot modify its value. Constants also called literal. We already use constants. Here 0 is a constant. And you can use scientific notation or floating point notation to represent a floating point number. For example, you want to represent 3,670. You can use the floating point notation or use the scientific notation. For scientific notation, we have many ways to express a floating point number. For example, you can use 3.67 followed by a letter E. This letter E can be either lowercase or uppercase. And follow E is the exponent. So E3 means 10 to the power of 3. So this number is 3.67 times 10 to the power of 3. And you can add a plus or negative sign after letter E. So for this example, here we add a negative sign after letter E, and this means 10 to the power of negative 1, which is 0.1. So 0.1 times this number is 3,670. So in this example, all the constants represent the same floating point number, 3670. We know that if you want to write 0.0, you can omit the 0. You just you can omit the 0. But if you cannot omit the decimal point. The decimal point is important because if you remove the decimal point, then this will be, generate an integer, not a floating point. So the data type will be different. You can do some experiments. Now suppose we Now suppose I want to know the memory size of this constant, then I can use the size of, and because it's a double, so this operator will return 8, because double occupies 8 bytes. And however, you can also omit 0. But if you remove the decimal point, the data type will be different. Now the data type is integer, and the integer has only 4 bytes, so this operator will return 4. So we should know the difference between integer data type and the floating point data type. The next slide is about another constants. This is this constant is character. In C++, we have the character constant or the string constant. The character constant is enclosed by single quotes, while the string constants are enclosed by double quotes. So the data type of the two constants are different. So you will notice you should notice that A enclosed by single quote and A enclosed by double quote, they are different. The first one is a character, while the second one is a string. It's actually a C string, and later we will learn more about C strings in later chapters. For now, you just understand the two constants are different. Actually, the memory size is also different. You can character A has 1 byte, so size of character A will return 1. But if you change it to string A, string A contains 2 characters, character A and the null character. So actually, this string will contain 2 characters, and therefore its memory size is 2. So later we will learn more about C string. The final constant is the Boolean constant. The Boolean constant is either true or false. The two are keywords in C++. In your IDE, here, bool is a data type. Then you can assign some initial value. You can assign true, or you see that true is a keyword. You can also assign false. You see the color is different because this is a keyword in C++. So for this data type, for the Boolean data type, its value is either true or false. And the true and the false are Boolean constants. Next, let's talk about a escape sequence. A escape sequence is like this. This consists of two characters. It begins from the backslash. This operator is different from division. You know, division is another operator. So division is this is division. So this operator is division. And this one is known as backslash. So sorry. So if you want to perform division, we use this operator. And if you want to use escape sequence, then we use this backslash operator. For example, you want to print a new line, then you use the backslash, and this corresponds to a character, only one character. So new line is it's very common. We use a lot of new lines. For example, you want to output some string. For example, you want to add a line break after hello, and you want to add a line break after word, then you can use the new line. This is a escape sequence. You can see the output after hello is a line break, after word is the second line break. And you can use another escape sequence. For example, the tab. Tab is also one character, and actually it corresponds to it's like a space. You notice that you see that after hello, followed by a tab character. This looks like 4 spaces, but actually they are different. 4 spaces corresponds to 4 bytes, but 4 spaces. But here tab only corresponds to 1 character. It looks very similar because you can try 1, 2, 3, 4. So you cannot notice this space is different from tab. So you from the output you cannot distinguish space and tape, unless you copy this output and count how many spaces. I can do this. For example, now we copy the program output. Actually, there are two spaces between hello and word, and only one tape character after word. And you can copy the program output. If you move your cursor after hello, you will notice there are two spaces after hello. But after word, there is only one character. You will notice this character only move one character. So from the program output, you cannot distinguish spaces and tape, but you can use your cursor to count how many characters. Another escape sequence is, for example, you want to print the double quote. Now suppose we want to print a double quote after the hello word, and if you directly input the double quote, you will encounter syntax error. This is because the double quotes should appear. We always assume the double quotes is a pair. So when it sees a double quote, the compiler expects a terminating double quote, but the compiler cannot find a terminating double quotes. So this will cause a syntax error. So what will you do if you want to print the double quote character? The solution is to use the escape sequence. You add a / before the double quotes, and you notice that the color becomes blue. This means a single character. This is the escape sequence, and then you can print the double quote. If you use escape sequence, you can print the double quote. Now let's consider another problem. Suppose you want to print /. What will you do? Now suppose you want to print /. If you compile this program, you will observe syntax error, because this is a escape sequence, and again, we have the same syntax error. The compiler cannot find a terminating double quote, because this is the first double quote, and this is not the terminating double quote. It's only a escape sequence. So here we should add a terminating double quote. But this is not what we want. We want to print the /. And how can you do to print the /? Yeah, the solution is easy. You just type the / twice, and this is again a escape sequence. So in this case, you can print the /. Is, you will encounter this in the path of the Windows operation system. Now suppose in this folder, you will observe that you see that this folder is C in the disk C, and followed by a backslash. So in Windows operation system, we use backslash as the to denote to separate the folder. So if you want to print the folder's name for Windows system, you will use the escape sequence to print the backslash. Next, let's talk about naming constants. Now suppose we want to compute the area of a circle, and you will use a constant pi, or you will use 3.14. This constant, you will use the constant pi. So you may repeatedly use this constant. However, this will be very tedious because you need to manually type this constant. You need to copy this constant many times. This is tedious, and especially if you require more precision. So you need to copy this constant in your code. So this is very tedious, and we won't do, and we usually don't do this. We seldom do copy and paste. So a better way is to use you might think, oh, we can use a variable to denote, to represent this constant. You can use you can declare a variable. Then you can replace this constant by the variable pi. And this style is better. Your code is more readable. And another important point is that you can easily modify the precision of this constant. So if you use if you use variable, you can easily modify the precision of pi. So you don't need to modify the value in each statement. However, this will cause one problem because some user might modify the value of pi. For example, if you call, for example, you perform some statements, you might accidentally modify the value of pi, and this will affect the computation of the area, of the circle area. So the best way is to declare so you so you see that the some users might modify the value of pi, and this will cause your program to not work properly. And therefore, we want to add a modifier before the data type. We add constant. Then this means this variable is read-only. It's a constant variable. It's read-only, and you are not allowed to modify its value. So this is what we call a naming constant. You give a name to this constant. So this is a naming constant. You give a name to this constant, and we declare a variable, and we add the constant modifier before this data type, and this variable will become read-only. The user cannot modify its value, so it is like a constant. The lesson has come to the end, so I think we can dismiss.